area on the curve under a continuous curve, it turns out that S bar, the upper sum, is actually equal to the lower.
Come on, sweetie.
Which is the same as sum. When the area on the continuous curve, that is a continuous function. In our case, we have this curve y plus x squared, or fx plus x squared, or y plus x squared. Y plus x squared, it is a continuous curve. And because it's continuous, the upper sum and the lower sum happen to be the same guy. Now, note that the upper sum is as tall as possible, and the f underscore is the smallest possible. So anything in between is the lowest. So basically, we have a curve like this, and then we have this, and then we have this here. And so what do? Whether we take this curve, whether we take this area or that area right there, when you let this n go to infinity, by the n is going to infinity, then it turns out the upper sum and the lower sum, they're all the same guy. Hence, we don't have to find both of these. We just have to find any one of these, or we can pick any number in the middle here, and then take the middle, make a rectangle like this. So we can even get rectangle. We'll use a midpoint here. If you use a midpoint here, at this point we get a rectangle like this, which is in the middle. This is not the short rectangle or the rectangle, but if we take the limit as n goes to infinity, then even this guy goes to the same guy, because the upper sum and the lower sum is what? Is all the same. So that's the theorem, which I'm not proving. Again, if you are a math major, then you will see this theorem. But if you're not a math major, you will never see this theorem. And I know that most of you are not math majors, so you will never see the theorem, but it is a theorem which is true. Okay? So we will assume the theorem without the proof. So that means we can now get the right sum or the left sum. So here, what we want to do is, now the question is, okay, so far so good. Okay, so now let's now move on to the next one. So what I'm going to do is I'm going to now save this, and next clear all this. So now let's now move on to the next example. I have many examples here. Each step is going to get what? More and more complicated, okay? So let's look at this. So now let's look at example 6. Example 6. What is example 6? Example 6 is right here. Okay, so example 6 is this. So let's look at example 6. Now this time what you want to do is find the area bounded by the curve, bounded by y plus x squared, and the y equals 0 and x equals 2. Oh. What that means is we now want to find the area of this y square under the curve y plus x squared. So not from 0 to 1. We now want to find the area of this guy not from 0 to 1, but 0 to 2. So what do we do in this case? Well, we want to find the area by the upper sum, but actually the upper sum is actually what I call the right sum. Why is it called the right sum? Because if you look at each interval here, this is I sub k, and this is x sub k minus 1, and this is x sub k this is x sub k. So the question is, which point are we going to use to get the height? So if you use the point on the right, on each interval, then that's what we call the right sum. This is the most convenient. So rather than the upper sum, you will actually find the right sum, which is easiest, because when the curve is kind of going up and down like this, and then we have let's say we chop the interval like this. So the question is, what is the upper sum? You know what? Let me do this again. Let's say we have like this, and then we chop the interval like this, 1, and then here, and then here, and then here. And now, how will the upper sum look like? The upper sum is going to look like this over here, and then over here, no, not that. The upper sum is going to be here, and then here. Oh, it's going be almost like three straight lines here. Okay, you know what? This is not a good example. You know, let me do this again. Okay? The graph is not a good graph. So what I'll do, how about this? You know what? Let me do this again. Sorry. Again. Let's say like this. It kind of looks like a nice volcano. So we have this here, and then what? Let's chop it up like this. 1, then 2, and then 3, and then 4, and then we have 5 here. So now, how will the upper sum look like? The upper sum is going to look like this. The upper sum is going to look like this. Oh, it happens in the middle somewhere. And then for the second interval is going to be this. And then for the third interval is going to be something like this. And then the fourth interval is going to look like this. So now, as you can see, this is a bit complicated here to calculate this because on this side, on the first interval, the maximum is over here. So we have to get that height from there. And then on the second interval, we have maximum height is occurring at the right end point. And in the third interval, the maximum is occurring over here somewhere. And then for the fourth interval, the maximum is occurring at the left end here. So this is very confusing. We cannot get this. So what we do is we're not going to use the right end point anymore. We are not going to get the upper tall rectangles. We will just get what we get from the right end point. So let me do that. From the right end point, we just get this guy. And then we get this guy. See here? And then we will get, for the third interval, we will get this guy. We will get this guy right here. And then for the last one, we will get this guy. So whether it be the short one or the tall one, we don't care. We will just use the right end point. Is that clear? If you use the left end point, let me now use blue. What happens if you use the left end point? The left end point, then we get this. Oops. How about if I use green instead? How about if I use tick marker here? The left end point, we get this. And the left end point, we get this. And then the left end point, we get this. And then here we get this. How about if you use the middle point? If you use the midpoint, then we get what I call, let me use orange. The midpoint here is midpoint, we get this. And then here, the midpoint here, we get this. And then midpoint here, we get this. And then for the midpoint here, we get this right here, and then we get this. You know all these different colors here? Red, orange, black, or green. It turns out that for continuous functions, once we let this n go to infinity, it doesn't matter which one we take, we will end up with the same number. That's what I mean by saying that the upper sum and the lower sum will be the same if the curve is a continuous function. If it's not continuous, so we may have some problems, but again, for continuous functions, or even piecewise continuous functions, the upper sum and the lower sum are actually the same. Whenever the function is continuous, or even piecewise continuous. So that covers almost all the functions out there which you have seen so far. Okay? Most of the functions you have seen so far, they're continuous on a closed interval. So now let's move on. Let me save this and then clear all this. Now let's do example 6 here. What is it? Oh yeah, I know how we're doing this, right? So the interval is now 2. So what is it? Let me use the red marker. So what we have is this right here. So we have what we have is we have this. And the interval is now from 0 to what? 0 to 2. So now chop this up into what? Into n equal to intervals like this. Dot, dot, dot. And then in the middle here somewhere we get this. The last interval is over here. And this is our x1. This is our x2. So x0, x1, x2. And this is x3. And then this is our kth interval. Let me call this guy I sub k. Well, I sub k, I have a little time like it. So this is I sub k. What is I sub k? I sub k is x sub k sub k minus 1 to x sub k. So that's how we define I sub k. The kth interval is the interval from x sub k minus 1 to x sub k. And the last one is, of course, x sub n. For Okay, so now what we see, delta x is 2 over n. And the x of k is actually what we call this is actually x0 plus k delta x. Again, x of k is always equal to x of x of 0 plus k delta x. In our case, what is x0? This is a, the interval is called a comma b. This interval right here. This a right here. A is equal to x0. And b is equal to x of x, basically. So anyway, in our case, the x of k is 2k over n. That's what that is. So x of k is 0, x of 1 is 2 over n, x of 2 is 4 over n, and x of n is equal to 2n. So when you substitute k equals n here, substitute k equals n, then we get 2n over n, which is 2. So the last guy is 2. The first guy is 0. And now, how do you get the sum? We are going to find the sum by the right endpoint. So the right endpoint, we are going to get this, and then we are using the right endpoint. So this is also called the right sum. In our, for example, 6, this is the upper sum. For example, upper sum is also the same as right sum for this problem. For this problem, they are the same. But they are not the same all the time. But again, to find the sum, if the function is continuous, then it doesn't matter which sum we get, which sum we calculate, we'll just use the right sum. That means we will always use the right endpoint. But if you want to choose the left endpoint, fine, you get the same answer. If you want to use the middle point, that's okay too. If you use the right endpoint on some intervals and left endpoint on some other interval, you still get the same thing too. So we have a complete flexibility here. Doesn't matter which point we use, we will end up getting the same sum at the end. So that's the good thing about continuous functions. So now x of k, and then now what is it? And then you now once you get to this, and now the rest is calculation. It's all the remaining is all algebra. You get that, and then you get that, and you follow this, and then at the end you get this, and then we take the limit here. What is a s sub r? What is that? That's the limit. We take the limit and of course infinity of this n partial of the right sum. In our case, this is the right sum. I'm going to call this s sub r. Right sum or the upper sum. Right sum because we are using the right endpoint. So that's why we have this here, f sub k minus 1 to f sub k. So the question is, which one do we use to get the height? If you use this one right here, we call this the right sum. This is I sub k. And on the kth interval, use the right endpoint. That's what we call the right sum, s sub r. Again, it doesn't matter, right sum, left sum, upper sum, lower sum, middle sum, no matter what sum you get, for continuous functions are all the same. So you have to just get one. When you want some practice for study, then you can use the middle point, left hand point. Why don't you check it out? Okay. Anyway, in this case, then you do that, you get, and then at the end you get this one. Final answer 1/4. And at the end, of course, once you get the final answer, I want you to check and see whether this makes sense. If you actually, if you actually look at the graph here, this graph right here, this is 2 to 0. And by the way, I do want you to estimate the area before you start. So on here, 2, what is that? That will be, what? That will be a 2. Well, the area of the entire rectangle is what? Is 8. And if you take half of this, the half of the rectangle is what? Is the triangle, which is 4. So we know that the area we have here is not even half of the rectangle. So we know that our area must be less than 4. But how much less than 4, that we don't know. Yeah, that much we don't know. So we know that it should be, the area here, let me write this down. We know that the area should be less than 4. Now this is the estimate. This is the estimate here. Estimate, E-S-T, estimate. If I prove estimate, area must be less than 4. How about if we chop up in the middle here? At 1, what's that? It's 1 right here. So this area right here we see is 1. So we know that this area must be at least 1. Somewhere between 1 and 4. So our rough estimate is between 1 and 4. So now, can you see why it's bigger than 1? Because this red part right here, which I colored, that part is 1. That's the square one. So we know that the area must be 1. And then maybe if we take the triangle, this guy and triangle that guy, I think it's going to be at least bigger than 2. Because this guy is what? Is almost half. And this guy, I think, is probably more than half. So I think the total area must be probably bigger than 2. And what is our answer? Our answer is 8/3, 2 and 2/3, which makes a lot of sense. Any questions here? Any questions, comments? Okay, then now it's here. All right. Now what I'm going to do is I'm going to scroll this over. Now let's look at example 7. Example 7 now, same curve, y plus x squared. Y plus x squared because we love our curve y plus x squared so much, right? So y plus x squared. Now this time, now it's going to be between x plus 1 and x plus 4. So find area bounded by the curve y plus 0 and y plus 0 and x plus 1 x plus 4. Now that means is we now want to take the area of this side here. And then what? Now this is from 0 to 4. Now the area is not from 0 to 4, it's actually from 1 to 4. Now to get the area of this curve from 1 to 4, of course you can get the area from 0 to 4 and then subtract the area from 0 to 1, but we are not going to do that, okay? That's too long. So we will just get the area directly. So what happens is the interval right here. Interval from 1 and then to 4. So chop this up into what? Into n equal subintervals. 1, 2, and then in the middle here somewhere, and then this will be this. And same naming convention, x0. And this is x1, x2, and so on. So what is a delta x? Delta x will be 3 over 1. So 3 is actually 4 minus 1. So 3. The length of this interval right here is 3. So we have to chop this up into n equal subintervals. So the length of each interval must be 3 over n. And what is the x of k? X of k will be 1 plus 3k over n. Again, this x of k, let me write this one more time. X of k, what is x of k? X of k is equal to k delta x. K is same as x0. So therefore, we see right there, xk is equal to 1 plus 3k over n. Now, we do the same thing here. We get out of all the n rectangles. So how do we get the rectangle here? Well, a sub k bar is actually upper. Because n equals subinterval. So you might actually see this one right here. X sub Rn, right? And n number of intervals. And so in this case, we get that, and then we get the same thing right here. Note that we have x of k, that's the sign that we are using the right hand. So you will use the right hand pointer, x of k. If you use left hand pointer, then you will use x of minus 1. Note this interval right here. This is x of k minus 1, and then 2x of k. So the question which one are we doing? And this is the I system. K interval is interval from x1 and k to x of k. If you use the right interval, that's what we call the right system. And then now once that's okay, it's this. So what that is the square function. So that. So what you do, you have to sum all that. So you get this. And it's what you get this. And now you split the sigma. And then you bring all the points. Now note that n is a constant, k is the variable. So note here, let me write this down. On this sigma. On this sigma. N is constant. K is the variable. So therefore, n we can put it out. When you look at the next step, 3 events came out, and 8 events came out, then 27 came out. And now it's sigma 1, sigma k squared, plus an n. And then now it's giving us this, so f7 bar, the n partial right sum. Now this is what I call the n partial right sum. The n partial right sum came out to be this right here. Wait a minute, what is this here? Oh yeah, this right here. This is the n partial right sum. Or if you will, you can just, stop right there. This is fine too. By the way, you know what, this limit right here? What is the limit of this guy as x is approaching infinity? Do you know how to compute the limit of this guy? You know what, in chapter 1, you remember this? It's like when you have a limit here and x is approaching infinity. Then x is approaching infinity, and then we have this, I don't know, this, what is it? This is x to the third power. We have x to the third power. How about if you look at this guy here? How about if you look at this guy? How about if you look at this middle guy? Because that's a little bit easier. So how about if I do a limit of x? This is limit of 18x squared. 18x squared plus 18.
I just hope something good happens because I'm feeling very depressed.
And then divide by 2x squared. Do you remember this guy? When did you study these guys? Remember this kind of problem before? When did you see this?
Chapter 1.
Right, when did you study this?
Yeah, I don't know.
We studied this. We studied these limits.
No.
These limits.
No.
These limits when?
No.
Limits
Why would you say something?
22 years ago.
That's not true.
Remember this?
No, I didn't. I never.
That's right. We learned those limits long time ago. By the way, in chapter 1, in I think the latter part of chapter 1, we studied those limits. And when we studied the limits there, we used the variable x. But here, instead of the variable x, now we see the variable n. If n has to be a natural number. Okay? But it's the same limits, basically. Instead of x, we have n. So now, and also we learned that when you have the same degree, then we just take the leading coefficient here, and that's what that is. So, that's what that is. And so, you know what, you don't have to give me the whole thing here, but now, if you attach a limit here, so now, if you now, let's see, how about here? Okay, now, if you now try to, let me see. Now, if you evaluate the limit here, so this limit right here, when n is approaching infinity, so now if you attach n is approaching infinity, this guy will approach 3 right here. That's the 3 right there. And then the middle term is 18n squared over 2n squared, the leading term, so we get 9 there. This 9 is that 18 over 2. And then the third term is what? Is this one? We have a 27 there. And note that the numerator is n cubed, it's a cubic. And then the also 6n cubed, it's also cubic, same degree. And so the limit of all that is that the leading coefficient, 27 times 2. So we get 27 over 27 over times 2, and then divide by 6, which is 27 divided by 3, which is 9 right there. So that's where you get the number. So if you do not want to write this guy right here, you don't have to. You can just go from here and then attach a limit here, and then you get this guy right here. So the answer comes up with 21. So now when you now you have 21 here, so now you look at this guy, this area kind of looks like 21. Let's see, at 4, this guy is 16. And at 1, this guy is what? Is 1. Okay. So what is like the midway here? How about if you try to get the area of a trapezoid? Do you know how to get the area of a trapezoid? What is the average of 1 and 16? That's about 8. It's actually about 8.5. About 8.5 is the middle. If you construct the trapezoid, and then the base is what? Is 3. So what is 3 times 8.5? 3 times 8.5 is about 25 something.
And it's just
So,
like,
but
no,
you know what? This guy is not. It's less. It's going to be less than the area of the trapezoid, and therefore it's going to be less than 25.
Like, oh, okay,
And our area is 21. Okay, makes sense. So you always check this area by estimates. Of course, you can go back and look for mistakes here, but rather than doing that, you know what? Try to check by estimation, which is a much better way. So if you, like, let's say, got the answer like 210 for some reason, then we know that 210 is impossible. On the other, if you get like 2.1, well, 2.1 can't be, okay, that's too small. Can't be. And then if you get like minus 2, or that cannot be, it cannot be negative. So all of these will rule out. For those of you who make mistakes, usually the numbers are way off. So checking by estimation is actually a very good way to check. It's not a guarantee, but it's actually a significant guarantee if you check by estimation. Again, area is a tangible, it's something you can measure, and so you can check by estimating the area. All right?
You can't tell me that's not true. And like all
So
my
now,
whole life,
so
they're like,
do you
never
think
be
chapter
peer
4,
pressured
in
into
chapter
taking
4,
drugs.
do you think
Never
chapter
let
1 was
anyone peer
over?
pressure you into taking drugs.
No, chapter 1 is
And
not
now
over.
they're like, you need
Chapter
to be,
1 is covered.
you need to take these
And
drugs.
then chapter
if
3 is
you
derivative. Is that
don't,
over?
we're
No,
gonna peer
that is
pressure
not
you
over.
until you do. And
So,
it's like,
in order to, you know, this chapter
what the
on
fuck?
this midterm 4 on chapter 4
the opposite.
will be cumulative as
And
well.
I'm not okay with
So
it.
chapter 4, chapter
Not
3,
on board
chapter
with
2,
it.
chapter 1, although the focus will be on chapter 4, but many things will show up, okay, since what we studied on day 1. So everything is, so it's
No,
cumulative, okay, basically.
That's not a smart solution. It's
Okay,
not
so now
the
what I'm going to do
environment,
is save
it's
this
like
and clear this. So now let's move on here. Let's see what we have here. So what we want to do is, I'm going to, let's see here.
nobody's walking up to
And
me
let
saying
me
that's
let me
to my
scroll
face,
this
but
down
it's
here.
out there, you
So yeah, we have more curves here right there. Now, now class, sometimes
so
when you do these, when you compute the limits here, sometimes you want to check, right? And some of you will say, well, how do I know the right answer? How do you know whether you did it right or wrong? For those of you who want to check, let's say your sigma skills is not quite strong and you want to test it out, what do I recommend you to do is I want you to do problems like example 8. Why example 8? Because when you do example 8, note that example 8 is actually under a line. Oh, it's under a line? Oh, that we know that one. So what we have is, we have what? We have y plus 7, 12
Oh, hell
plus
no,
3.
I'm
This
not
guy,
getting that
this
done.
guy's y is
There's
what?
another
2x, and then what?
regular
Minus
one coming out.
2x
There's a
plus
regular
3.
vaccine coming out.
And then what is it here?
They made it
We want to
at
find, get the
Baylor,
area
Texas.
between x
It's
equals
a
what? X
regular,
equals 4 right here,
viral
and x
vector,
equals 7
you know,
over here.
which I don't want. 7 over
I don't
here. So
now
want
you
to
get
take
the
any
area
of
of
it,
this
but
guy
like,
here.
if they absolutely
What is
force
that?
me to,
For that
I'll
thing?
take,
What is it? What
maybe
shape
take
is that?
one.
That's a
But
trapezoid.
you know how I can't
So
handle
can you get the area of a
it. Like,
trapezoid?
my
Yes,
body
you
just
can.
doesn't
So if I
go
give
with
you a
it.
problem like this on the test, of course you don't have to do this by the sigma
Every time
limit
I
sigma,
do.
because we know the area, we know how to do this. So this example is just for your practice.
Damage my brain.
I will never give you a problem like this on the test. This one, you know what,
I'm
you
serious.
can get the answer without calculus, right?
I knew something was wrong with my
Because
brain.
because the trapezoid considers a rectangle and a triangle, so you can just get the area that way. Okay? Or anyway, you have the trapezoid area formula. The base times the average height. The base times the average height is actually the area of the trapezoid. But now, what we want to do is we want to now find you by limit sum, by the limit sum, by Riemann sum, we want to find the area. So now, in this case, what do you do? Again, we'll just we'll get the upper sum. However, it's not really the upper sum. What we are really getting is we're not getting the upper sum. We actually want to get the right sum. In this case, the function is actually increasing, and therefore the upper sum is the right sum. However,
no, I went to go get
we are really trying to find the right sum, which is the easiest.
Close on Sundays
Upper
because
sum,
of the,
little bit more difficult.
January, I don't know why, but I guess
When in case the curve is going up and down. By the way, when you look at example 9, this is where the problem begins. This is where y equals example 9. We have y plus x squared plus 1. the graph is actually going like this. And then you know what? Interval from -1 to 4. Oh no, look at this. From -1 to 4, -1 to 5. So now what you see is that, now this part is increasing. So when you chop it up here, the right sum is the tall guy. But from this side, left of the y-axis, you chop it up right here. So now what is it? The upper sum has to be from here. So now it's getting complicated.
Yeah, but it's also something
But it turns out that
I feel like they're
so if you want to find the upper sum, that's complicated. So we don't want to find the upper sum. From here on, we will just be getting the right sum.
I think
Just
I'm
use the
gonna,
right endpoint. It's all the same
are
anyway.
you serious? I feel like that
So
should be
we
the
will
one
be
place
finding
where
what?
you're
We will be
should
finding the, you know what?
sheltered from
That's
indoctrination.
partial upper sum, that's a mistake. I should have fixed that. That
You know
should be
they
called what?
fired the medical
Instead of
ethicist
x and then bar,
at
I
UCLA
should write this as what?
because he was saying it's not ethical to mandate
I should.
an
I
experimental
think I
vaccine.
should call this what? I should be calling this guy this. I should be calling this guy as a what? Right sum with n intervals small n. And this one, I should not call this by S bar. Oh, I did call this
Well,
right
then there's
sum. though.
enough and they need to stop.
I did
now.
call this right sum, but I didn't write the right sum in
I think
location.
they're
The right
recalling
sum
the mandates
location
in a
will
lot
be
of
S,
other countries like Israel. I think they stopped them.
S of R.
And oh yeah, they never had them. They never had them in Japan.
And n
Japan has
partial
the
right, I
lowest
didn't
rates
call
of
this the
COVID,
right
and
name.
they've never had
N
them.
partial right sum. N partial right sum is this guy here.
And
The
they don't
notation
do
which I
like
wrote down right here,
forced
that is
quarantine.
what we call the n
Like
partial
they
upper sum.
ask you to
But
quarantine.
here we are not going to
but
write
you're
find the
allowed to
upper
do it
sum.
at home.
This upper sum
In
is
Australia, they
complicated
will come
when
and
the
get
when
you
the
and
function
put you
is
in a
going up and
bag
down.
against
So
your
we will
will.
be finding the
lock you
right
up
sum
in a
only. That's all we have to
maximum
worry.
security
Unless you want to
quarantine
find the
facility.
left
And
sum
people are like,
or
it's
the
okay,
middle
it's
sum
justifiable.
or any kind of combination sum, you can do that. But by far the easiest is right sum. When you study, I do recommend you to find the right sum. Okay, so
I'm
that's the
surprised
other
because
sum,
I
like
thought
left sum
Australia
or
was
the
kind
middle
of
sum.
behind it. But my
Or,
Australian friends,
or we have other
my
groups.
Australian
But anyway,
friends are
you
the
can pick
worst.
anything
They're
on
the
each interval.
worst.
Okay,
They're
so
the
now
most
that's
Fauci loving.
so now one second in this case, what
Triple
is that okay?
masking, triple
So
jabbing,
delta
like
equal to now 3 over n.
it just blows my mind. I'm like, who are you? They're like these real granola hippie
So
vegan
delta x
types.
is equal to what is equal
It
to
doesn't make
b
sense.
minus
to me.
a
It doesn't make any sense.
over n. That is if the interval is
They're like
A,
all
comma,
natural. And
B.
then listen, my one
we
Australian
assume that a
friend,
is less than
Anna,
b,
she's a
of course.
model. She's
When you
so
write this, and so
healthy.
delta
She's
x is
like
this
the
right here, and
most
that comes out
she's
b3 over n. And
super
x the
healthy.
case now, this
She
guy
got
here,
the
once again, what is
vaccine,
delta x? Delta x
4
is
months
equal to
later
a
or
plus
6 months later.
k delta x. I
I
will
can't
count
remember
that
exactly,
formula a
4
few
to 6
times now
months later.
already.
She had
So
to
that will
have
be
her
4 plus,
uterus
and a
removed.
k times
She
delta
had
x, delta
all,
x 3 over n.
like,
So we get this. And now,
literally
so what is
more
that right there?
fibroids gone on her
We get
uterus than
this.
the size of her whole
and now
uterus.
this is this right here, and then this, and now we get this. We are using the right hand sum. X and k is this guy, plug it in. Now from here on is all algebra. So you don't need the graphs anymore. So from here to here, you need the graph, but here now we have everything is algebra. And now we look at this here, we have to go through this. Now, what is this here? This is
I don't see how
f of 4
perfectly
plus
healthy,
3k over n. Now we have
like,
to plug in this
vegan,
into the function f.
gorgeous
Our function
model,
is right here. This is our
thin,
function.
young, healthy
So therefore, this guy
model
4 plus 3k
can't
over n
put
is now
2 and 2
plugged in
together
here.
that you
So
shouldn't
that
have
is
to have
our
your uterus
F of
removed when
X
you're
of K.
under,
That is our
you know,
f of x of
45.
k is this guy right here.
like, there's something not
So
right
x
about
plus 3,
you
x
having had your
now
uterus
4
removed.
plus
Do you
3k.
not think maybe
And then,
that that
you
shot,
event,
the
which is
weird
delta
shot
x.
that you just got,
And then
might
now
have something
by
to
that
do
you
with
get
it?
this,
That's
and
been
then now
considered
multiply
wrong.
out you get this, and then split the sigma, and then split the factor out all the constant factors here. Note that n is not n is a constant, k is the variable, and then you type the limit, and
What,
then
like
you have
heart
now this, and
attacks?
then you get that. So that, and then you get this. If you
that
want to stop
Bob
right here, that's okay
Saget
too.
Saget.
on.
Yeah, Bob
He
Saget.
just said it, but 3 days before
Now if
he
you
had
take the limit as n is up to infinity, now you can
Are
see
you
that the
serious?
33, and this guy is 18 over 2.
and they said
This
that is a
is the
fact.
quadratic in the numerator.
Now some
And it's
said
also
Betty
quadratic
White
in the
did, but
denominator,
everybody,
same
I've
degree.
seen two where that
So
was
yeah,
fake.
back to chapter 1.
Yeah, I mean, also at that age, like anything can kill you, you know.
All of you remember
Yeah.
that living stuff?
But the point is, it's about choice. People don't want to
That was
choose.
long time
You
ago.
can
But anyway,
you
I got
can
to
maybe
look
not
back.
catch the virus. You know,
42.
Yeah.
maybe you won't
Not
catch it.
the area
Maybe it won't make you
42.
that sick.
That's it.
But if you
It's the
have to
area-
choose to go and like
It is 42.
put, like
This
if you're
side-
being forced
this
to
side
put
is,
the shot in your
the
body,
next
that's
figure.
like you're
Now, for the
guaranteed
hospital,
the risk that comes with it. It's just
area
like
of the hospital
I
is
don't
if you call it
And
the
some
base
parents are doing it because they're threatening, like,
Or
if
anyway,
you go back to your kids' school, like,
they're
there's
trying to
way,
take them
they
away.
can turn human services in on
and
you,
that will
they
be
can
a
take your
base
kid,
time
they
the
can say you're
average
a child abuser or neglector. You know, so some of the parents, they won't give their kid what they won't take themselves, so they're taking it with their kids.
The area of that rectangle
Oh,
which I
that's so
do right
sad.
here
That's so
is
horrible to
exactly
put
the area
people
of the
through this
hospital
shit.
right there. The area of the
And one
hospital
lady,
is actually the
she
same as the
did
area of the
that,
rectangle which
she
is
took
do
the
right there.
jab,
And the
and
midpoint
she
is
had
actually
6 small
5.4.
children, and
No.
black
At
everything.
4 this is 8.
She
And
died.
then at
No,
what,
see, you can't do
what is
that,
it,
like-
at,
She
7.
died and she had 2
14,
small
this is
children, like
17,
under
right?
5 years old. And the first one they were trying
This
to make
right
cake,
here,
you know,
up
for
at 5.5.
school age.
What is the midpoint there?
I can't believe they're
0.5.
giving it to
This
babies.
is
That's
actually
just
what,
crazy to me.
12.5.
My friends vaccinated their 6-year-old daughter. She's 6 years old.
That's
Did
all.
I get this error correctly?
There was
I
a
made a mistake
15-month-old baby who died in
What-
LA
what
this
mistake?
week
What mistake did I
after the
make?
COVID shot.
Oh, sorry.
They gave it to a
If
baby?
X equals 5.5, and you got, oh, you know what, this is not 12.5. It's
Oh
usually what,
god, that's too little.
7 here, we get what, 7,
Yeah,
14
like
to
Maya's
7.
age.
When you plug in 4, oh, you know, it's
God,
not 8,
they're not
it's
gonna
11.
give
This
it to
is
Maya.
11.
No, Athena's
It's
got
11.
herself up in
And
the
this
woods
one
and
is
she
not, this
ain't
is
gonna.
actually 14. This one is
She
actually
lives up
14.
there with Chris Saint.
So the
That's
area of the
Paul's
chapter,
brother
if you have
in
in
the
this
same
form,
town.
it's going to be the
Why does
base
he live there?
times the average height.
He's
By
built
the
a
way,
whole
the area of the
Silicon
chapter
Valley
is
up there.
equal
It's called
to
Rockland,
either the
California.
base times the
which is
average
right
height,
below,
or it's the
Colfax.
average base times the height.
And there's like a bunch of like taking people.
Again,
up
area of
there.
the chapter is either
They built the whole
base
city.
times the average height, or average base times the height. If you have a rectangle like this,
He lives in Colfax, which is the
you have
city
a chapter like this, the area of this side is going to be
just north of
average
it.
base, that is base of the top and the
I don't
bottom.
know why anybody would want to live there.
If you have a rectangle this way, then the area of the area of the chapter is base times the average height. So either base times average height or average base times height. Doesn't matter which one.
Oh, is he still
So anyway, in
working?
this
I thought he
case,
was
the
old.
answer comes out to be 3 times
younger
14 is
than
actually
Paul.
42. In this case,
Oh,
you know
okay.
exactly how to get the other
Oh,
stuff.
isn't he like all
15
gray?
times 42, and as you can see, you do
Well,
the 42.
yeah, salt and
In
pepper.
this case, you can actually check.
You know, they all have that early graying like Jack did.
Actually,
He didn't have gray hair.
actually what?
Jack didn't,
You're actually.
Jack didn't have gray
This is
hair.
not an estimate.
Yeah, Jack had
For example, 8, this is not an estimate, it's actually a full check.
Really?
Because
I
the
don't,
area is 42
oh, I
chapters.
don't remember that. I thought he had blonde
So
hair.
if you feel that you need to
I died.
check the
I
answer,
started dying.
then
but
do
when I
times like
met him,
exact
he was
answer.
already completely silver.
and if you
Oh,
this is
really?
47.
Oh,
Try
that's just
48.
genetic then.
Try from let's say from
it's
1
genetic.
to 5.
Well, the
Okay,
blonde looked
different input.
natural.
So that's how you
Yeah,
can check your check your sigma.
Man, I have a
six,
headache. I don't know what I'm gonna do. I guess
you can
Probably
check, and
the
then once you
COVID.
get
I've
good at
been
it,
getting COVID
then you
headaches.
can now
too.
get into the quick
no,
line.
mine's like
Like next
tension.
one, now example, now let's
Really,
look
when
at
I
example
look
9,
up,
we're almost done
sometimes
here.
when I first
So
get in
let's
the
what is
morning, I'm
example 9?
really to
I
And
think
so
there's
what is this
I
right
think
here?
there's a gas leak in the house.
Okay, okay,
I'm
so let me
starting to
say
wonder.
this.
I think there is. I really do, Mom. We need to get it checked out. Can you just call the gas department and have them come by? They don't like they'll come by. Say you think you got a leak, you smell gas, and you got a
Okay. All
headache.
right, I will.
Okay, I love you.
I love you. Keep me
So what is the
posted,
delta
and I'll
type?
see you
The
soon.
delta
Okay,
X,
bye.
oh yeah, you know
Alright,
what, let me
bye.
say,
Stay
I think I
strong.
saved this, so let me clear all
Things are
this.
gonna get better.
And let me now
Hey,
bring
was the
this
package
down.
there? Was it
Let me
okay?
Scroll this down.
Yes, it
So
was.
we get this
Everything's
right here.
fine. Don't
Oh
worry.
yeah,
Did
this
you
again,
rush
the
in
last
and like
example
get it in?
is this right here,
Yeah.
and then this is
Okay.
what, let's say
Nobody's gonna come
example
up
8.
there, but
I should be
I know.
writing the
And
slide
Anthony's
from,
got
and I'll
cameras
just slide it in
everywhere.
Tinker.
yeah.
So anyway, this
And
one,
we got a
we are not going
camera
to find the
too, so
right
we can see
one, we'll
everything that goes
find
on
the
in
upper
front of
one.
the
So let me
house.
write
We
this
got a
down.
cam-
I'm not worried
So
about
this
people
one
stealing
here, we
anything
are
or
going
they're
to,
gonna
let's
get
call
caught.
this the,
Oh, we
we
got
are
a
doing
camera
this
too.
one, will now call what? Will
Yeah,
be
there's
called
one
the
down
right
on my
sum
garage.
and partial
Okay.
right
You
sum.
just have to hook it to your computer.
R,
We should
and
get a
this will
few.
come to find.
Yeah.
And
I've
then
got
not
a
the
pet
upper
camper
sum, we are going to
for
call this
7.
the right sum.
Yeah, that's
F
smart.
R with
Even
no N.
that small works.
This is called
Okay,
the
all right.
right
I love you. I'll call you
partial upper
later.
sum.
Bye, I'll
No,
see you
sorry. Right
later.
partial
Bye.
sum.
Bye.
And partial right sum. And partial right sum. And this is called the right sum. And here I should be changing this notation too. This should be right sum. Right sum is not this. Is the sum, right, and then n, and as n is that portion infinity. So that's how right there. So I think I need to change all of these notations here. So when I was writing these notes, what was I doing? I was watching a soccer game and eating my favorite burrito. That's what I was doing, right? So I couldn't pay attention to writing my notes. Sorry about that. So I guess I'll have to fix all of these guys here. So delta x is 5 over n, and x to k is equal to negative n plus 5k over n. Now, when you write this xk here, I want to check. How do you check? Check x0. What is x0? x0 is equal to what? Is equal to minus 1. Therefore, it's right. Now, check x of n. What is x of n? Check x of n. Substitute x to k equals n here. So when you do that, then what do you get? We get minus 1, and then what? Plus. We get plus 5n over n. Oh, what is a 5n over n? That's 5. So negative 1 plus 5 will be 4. Okay, good. So now it checks out. Please check at every step. And then now f of k, what is it? Now we plug this in into our function x squared plus 1. F of x is now x squared plus 1. So you plug it in, and delta f is 5n. Now from here it's all algebra. Multiply this out, and split. And then what? Pull out all the punches out. And then you get this. So you get this right here. You can just leave it that way. And then now take the limit as x goes to infinity. That will get to the right sum. This is a partial, this is what the n partial right sum. Now you get this. It comes out to be this guy right here. And you should estimate it. By the way, before you start all this, I want you to estimate. Always estimate at the very beginning, because once you get the answer, it's hard to estimate, because you already know the answer. Okay? So you're now going to gear towards the answer. It's not a good thing. So I want you to estimate before you know the answer. So what do you do? Estimate before. So what I ask you to do is estimate the answer before you calculate. Okay? How about this? Before you evaluate. Calculate sounds like too much of a primitive term, so let's use the word evaluate. Okay? So estimate your answer, estimate the answer before you evaluate, and then you can check, and then use the estimate. Use the estimate to check at the end. All right? I think this is a good strategy.